Hello and welcome to Universe Sandbox 2. So I have a suggestion from AAV asking, what if Earth was 5 times the mass of Jupiter? So let's go ahead and find out. So here's Earth over here. I think I'm going to leave in everything, including the asteroids, because I think they might actually get affected by this. And it'd be fun to watch them just all fling out. But that also means we're not going to be able to time-lapse very quickly. So let's go ahead and get a comparison here. Earth is one mass of Earth, of course. And then we have Jupiter, which is equivalent to 318 Earth. So if we were to make Earth on a scale of Jupiter 5 times as much as Jupiter, that would mean it would be roughly 1,300 times the mass of Earth. So let's find out what happens. Okay, so here it is. We have Earth. Let's go ahead and halt the simulation real quick. And let's go ahead and drop in another Earth right here. This is how big Earth is now compared to the previous Earth. But that shouldn't be nearly as big as Jupiter. Yeah, Jupiter is still bigger. But Jupiter is also a less dense object. Let's go ahead and hit play. Immediately, I can see the sun actually curving a little bit more harshly than it typically would. It's always pulling towards Earth now. I'm not seeing any immediate effects. I don't know if Venus was always that eccentric. Now it's going to start pulling Mars closer since it's orbiting close to Mars. And it's going to be little effects like that. As Venus pulls closer to Earth, it's going to start dragging in a little bit closer every time it orbits, basically in sync with Earth. And it's going to be little effects like that over a long period of time. So what we're going to do is we're going to close all these menus and speed up the simulation. As you can see, Venus was ejected out into a very eccentric orbit. Let's go ahead and show the orbit map so we can actually see how much they fluctuate, and let's break off from Earth. Keeping note that Earth is the blue line right there. And Venus is now orbiting entirely outside of Earth, and I think we just lost Venus. It might have actually collided in with either Earth or the Sun. I don't think it was flung out of the solar system. Interesting. So we have lost Venus, and we still have Ceres, Vesta, and Mars. I don't know if Mercury will be affected since it's actually closer to the Sun than it is closer to Earth. Oh, Mars is getting a little bit more eccentric. I don't think Vesta was always on that orbital path either. And I guess from here what I could do is I could probably just go ahead and slow down time a little bit to maintain simulation accuracy, and let this game run for about 30 or 40 minutes, and it'll be a beautiful time lapse, which I've not done in quite a while. So let's see what happens. Okay, so I am back, and a little bit too far away from my microphone. There we go. I think what I'm going to do is I'm going to go ahead and clear the asteroids out, because the most they're going to do is fling out. I don't think we're going to have any cool collisions at all. We might, but the chances of it are very, very slim. So let's go ahead and delete all particles and dust to increase the performance of the simulation, and let's get rid of all these unnecessary objects I don't think are really going to be too affected by this. This way we can speed up the time lapse while still maintaining some simulation accuracy, because the more you speed it up, the less accurate it gets, especially when there's no available CPU cycles for it. Pluto in place. Let's go ahead and get rid of ones, and I don't think that's going to be affected at all. As you can see, Mars has definitely changed its orbital path. I don't see any effects on Jupiter though, which is kind of interesting considering, well, Earth is 5 times the mass of Jupiter. But that is still a pretty great distance between the two. Oh, let's go ahead and continue the simulation. So I am back once more. I've noticed that something has actually happened. Since due to the sudden increase in mass of Earth, what is essentially going on is, wow, look at Mars's orbit. What's essentially going on is the sun is actually drifting towards the point of where Earth originally increased its mass. So that's kind of interesting. We do have the sun actually drifting along in space now, which normally is true, but in this situation, it's typically a still simulation, and that would not actually happen unless something were to start pulling on the sun. So I'm kind of curious, whatever happened to Earth? Wait a minute. Venus is not gone. It instead went into a polar orbit around Earth. What do you know? I thought Venus collided with Earth, but I guess Venus is now a moon of Earth. Isn't that cool? I did not expect that result at all. I've never actually seen that in one of my time-lapse simulations before. That's very cool. Yeah, I thought Venus either collided with Earth or was ejected out of the system or something like that, but no, it's actually just hanging out as a moon of Earth. Very interesting. Wonder if that'll happen to Mars. Let's find out. Because Mars is getting kind of an inclined orbit. I'm gonna go ahead and speed this up a bit more. Nope, it looks like the frame rate just tanked. It's doing that thing I've mentioned about in previous videos where over time the performance will get worse and worse. Isn't it always out here? Yeah, I don't even know. Well, it's doing that thing where performance gets worse and worse with the progression of the simulation. Mars has been doing some crazy things, but now it's kind of like outside of the orbit of Jupiter. It like orbits within and then goes outside, and it's in like a crazy inclined like orbit. Same, probably a little bit more inclination than Pluto. So that is pretty crazy, but I think I'm going to go ahead and call that the end of the simulation because performance is bogging down over time. Because earlier we were capable of doing around 6 years per second, now it's... Actually, no, it's kind of maintaining that. But, I'm pretty much out of time for this recording. Again, it would be really cool if I had like a dedicated PC for this to actually be able to just run these kind of simulations for like a few hours or something, but I don't. Maybe this might be revisited if I get a second computer that I could actually do this on and like leave recording for like a day or something like that. But I think I'm going to leave it how it is. Right now, Mars is currently in a crazy inclined orbit, almost on the same, probably a little bit higher inclination than Pluto. And, well, Earth has a new moon. I think that is very cool that Venus is actually the moon of Earth now, considering Venus is around the same size as Earth when Earth is in its natural form, not 5 times the mass of Jupiter. So that is very cool. Anyways, if you guys liked the video, please subscribe, and until next time, I'll see you guys in the next video.